Hello everyone and welcome to another update on my 3D printed F-111 project. This right here is the first prototype that took flight, and I am saying that technically the flight lasted for a whole 5, maybe 10 meters, but it still flew, so that's better than last time, but obviously we still have some things to work out. And I'm gonna tell you all about what we did, what we're gonna do, and what I've already done for the next phase of this project after this message from our sponsor.
Before we continue, I'd like to thank my sponsor, PCBWay. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today.
So, yeah, we have done a test flight finally. Actually, a couple test flights, but they all more or less went the same. The main issue with the design right now is that it doesn't have enough lift. So, we can't really throw the plane fast enough for it to fly. It would fly if we could get it faster. We have proven that the aerodynamics of the plane are fine, but with the added weight of the battery and all the electronics, the weight goes up so much that we would have to increase the speed to still get enough lift to keep all of that airborne, and the problem is we can't get to that speed, not without a catapult. And even if we had a catapult, you would have to keep that speed up mid-air, and that would be very problematic once you do sharp turns. So right now, this design is too heavy to fly, or in other words, it doesn't have enough lift to fly. So that's the big takeaway from this phase of the design. And there's a number of things that this tells us, and there's multiple ways on how we're going to solve it. One of the ways you can actually see right here. But we're going to talk about that in a bit. First, let's talk about the test flight so far. So, this right here is the plane that flew, and the wings say SN-4.5, but this actually isn't SN-4.5. This is SN-4.1, the plane you saw me prepare in the last video, but its wing and fuselage section have been replaced. This is the old section that was cut out, as you can see right here from the infill showing, because the test flight opportunity came somewhat randomly. We weren't expecting to be doing a test flight that day, but it just came up, and I quickly grabbed SN-4.1 because 4.1 was ready to fly. 4.5 was not yet ready. A lot of the parts are done, but it didn't have any electronics installed in it. The parts were not glued together yet, and there was not enough time to do that. So I grabbed SN-4.1. But if you remember from the last video, 4.1 still had the thinner profile wings. So 4.1 has the NACA 2410 wing profile, whereas 4.5 and anything after... Sorry about the noise, by the way, it is very hot today, and it seems like someone's turned on some sort of shredder outside. That's not annoying in the slightest. Yeah, while we're waiting for that to stop, I guess. Also, sorry about the desk and the floor around the desk looking like a mess. I was working on a different project last night that is gonna take a bit longer to make a video about. The noise is still not stopping. I guess we are gonna make a video cut then, because I do not want to continue the video while this is blaring in the background. Thank you, Mr. Neighbor, for doing that. I'll see you soon. So, it seems the noise has gone away. Anyway, so SN-4.5 and anything after that moved to a slightly more efficient wing profile, that being the NACA 2410. You actually have a wing section right here, so that is what that profile looks like. It's just a little bit thicker than the 2410, meaning we get more lift at the same speed than on the 2410. So Really, there's no reason not to go to this wing profile, other than that I have to redesign the fuselage to be a bit thicker again. It wasn't as big of a redesign as it was from SN3 to 4, but it was still, like, the entire top section of the fuselage had to be redesigned again. It's just I took enough backups from when I did the redesign the first time that I just went back and, like, made a new branch, sort of. But yeah, so I wanted the bigger wing profile because I already kind of thought, you know, maybe this is a bit too heavy because we're getting about 350 grams of thrust from this, and the weight is more in the 400 plus gram territory. So we're not doing too great, and to be honest, the wing area is pretty small. The F-111 is not a low wing load design, even if the wings are pretty long and kind of look like a sailplane. It is pretty high wing loading, so you already need to go high speed anyway. So I just wanted the more efficient wings, and what I ended up doing is just cutting the fuselage segment out, because the thicker wings need a different hole in the fuselage to fit into. So I took the wings from 4.5, made the new fuselage section at my parents' place, which is why it's red, because we only have red lightweight PLA there. Glued it in, and flew that. And yeah, so as you can see by the plane still being in one piece, it did mostly survive the test flights. There's some damage, like this elevon being ripped out and the wingtip here being broken. But that's easy fixes. Like, this plane can be put back into flight ready state quite easily again. It's just that it won't really fly that far. So we're gonna move to a new prototype that's gonna be better. Like, I knew this going into the entire project. I was gonna be producing a lot of prototypes that were gonna fly once and then be retired. So before I rip all of the electronics out of this and transfer it into the new prototype, let's take a bit of a look at what's all inside of this and how this thing works. So first of all, this right here is the LiPo pack that the plane flew on. This is a 4S, so a 4-cell LiPo pack with a 1300 milliamp hour capacity. This weighs about 170 grams, and this is one of the main reasons why the plane didn't fly that far. Because this pack is a little bit too large, perhaps. I saw people fly similar planes with an 800 milliamp hour pack, and that is a lot lighter than this. So we could have saved quite a lot of weight that way. To put this into perspective, this pack is 170 grams. The entire fuselage, all the 3D printed parts together, is only about 190. So the battery is quite a significant amount of the weight, and reducing that would have very probably helped the plane fly just a little bit further. Then what we have in here is two 20 amp ESCs. You can just kind of see them like that. I removed the heat sinks from them to save some weight because they are in the airflow, they're in the inlet. They're gonna get enough cooling anyway, and we can save those couple grams. So we have two 20 amp electronic speed controllers because we have two electric ducted fans in the back. Before those electric ducted fans, we have two generic 9 gram servos for the elevons. And that's all the servos we have. We have no rudder, we have no ailerons, just the elevons. Which gives us quite a lot of control, actually. Like, this is only a 3/4 channel plane if you want to have the electric ducted fans on an individual channel. But because they are elevons, they work as ailerons and elevator at the same time. And a rudder, you don't really need a rudder, especially on a small plane. They fly just fine without. You just need a tail fin, and that's fine. And then when it comes to the electric ducted fans, you can see them in here, kind of. So these are 30 millimeter electric ducted fans. They're rated for 9.7 amps at full power. So the 20 amp speed controllers are a little bit overkill. That is something we can also save weight on to move to smaller 10 amp ESCs, which are gonna be smaller and lighter. And yeah. And these EDFs, they are QX motors. I forgot the name. I think QF1150 something. I'm not entirely sure. But they're 30 millimeter QF motor, 5 blade electric ducted fans, designed for 4 cells maximum, so we can't just put a higher cell count battery in this to get more thrust. So yeah. And then we also have a receiver in the front here, but that's taped shut, so I can't really show that right now. It's a bit of an overkill receiver. It's a 6-channel with gyro built in. We would have been fine with a generic 4-channel. And let's talk about how we're gonna be improving the design. There's 3 main things that we can do to improve the lift or reduce the weight problem. The first off, very obviously, is reduce weight. We already talked about a lighter battery, lighter electronic speed controllers. We can move to lighter servos as well. Like I said, these are generic 9-gram servos. There are 5 or 3-gram servos that we could try. And then there's the last thing, which is optimizing the 3D print profile. So that is actually something I have done. I have sat down and optimized my lightweight PLA print profile a bit, and I have managed to reduce the weight of the 3D printed parts by quite a significant amount. The thing I'm not entirely sure about yet is if they are still strong enough. Because the old print profiles, the ones that this prototype was built with, the temperature is 230 degrees, the flow or extrusion multiplier is 55%, and the outer wall thickness is 0.5 millimeters, and then everything else is 0.4 millimeters. And the new profile, which these new prototype parts are already printed with, is now at a higher temperature. It's at 250 degrees. It has an extrusion multiplier or flow rate of 40%. And I have 2 different versions of it. One which still has the 0.5 millimeter outer wall, and one that moves to a 0.42 millimeter outer wall. Now the 0.42 millimeter outer wall profile that's not gonna work for structural parts. The outer skin is very weak, it buckles very easily, especially with the 5% infill, so that is not gonna work for any structural parts, but it could work for things like hatches, covers, stuff that doesn't see any structural load, like stuff that's just cosmetic. So we can save a little bit weight like that. Because the non-structural profile is a whole 31% lighter than the old profile, whereas the one that still has the 0.5 millimeter outer walls is only about 23% lighter. That is still a lot of weight savings, but yeah, I mean that's also quite a difference between the 2 different profiles. And with that, we could bring the weight down. So if we stayed at the same design and just printed with the new wing profile, all the 3D printed parts would now be lighter than the battery. So that's cool. But that's not the only thing we can do to improve this plane. The second thing we can do is trying to somehow get more thrust out of this. Now, I already touched on this. We can't go to a higher cell count battery because the EDFs, they will not handle it. They already get very hot at 4 cell. And a 5-cell battery would also be heavier again, so like really we're shooting ourselves in our own foot. One thing we can do is trying to improve the air ducting. That is actually something that's changing for the next prototype, but it's not really changing because I'm trying to improve performance. It's just I'm trying to improve strength of the parts and the ability to add a landing gear for the full-size model. Because we're moving from this, you can kind of see it here, basically the entire inner volume is just air ducting, and we're moving to an approach where that's no longer the case, where we get just enough inner volume to get enough air for the electric ducted fans, and not anymore. Because as it stands right now, the outer walls are very, very thin. That is the main reason why the gear buckled on SN2 when we went too fast. And it also means that, well, the landing gear, when it has one, is just going to be inside the air ducting, meaning there will be a hole in the bottom as well, where SN2 also had the problem of sucking in grass and debris when it was on the floor, and like just really it's not that great. So we're moving to an air ducting design that is a bit more restrictive, but still has enough area to flow for the EDFs. So it's not like it's choking air, but it's going to be a bit smoother because the landing gear will no longer get intersected, and the outer walls will be a bit thicker and a bit stronger and all that stuff. But yeah, like we could try to optimize the air ducting a bit. I don't really think we can get that much because we're already getting the sort of 350 grams of thrust, which is what other people who have actually done CFD with their air ducting have also gotten, so I really don't think the EDFs are gonna get any more power out of this. that brings us to the last thing. And the last thing to improve lift is to just, well, make your wings larger. You know, you got more wing, you got more lift. It's that easy. Well, it's not quite that easy, because we're still building an F-111 here, and we can't just give it like F-22 wings, because then it's no longer an F-111. So the wings are already, they're already not quite scale. These wings are a bit longer, they are a lot thicker than on the real thing, and we're just kind of really at the point where we can't really stretch it anymore without it stopping to be an F-111. We still plan to have a swing wing version of this, so we can't just make the wings deeper either, because then they wouldn't be retractable anymore. So we can't really do that, but what we can do is where this comes in. So you see, this is the nose section of the next prototype, and you can see that it is a decent bit larger. So while we can't make the wings larger, we can just make the entire plane larger, because then everything lines up again. And as it turns out, you don't gain that much weight by going from 50% scale to 65, which is the scale that we're moving to for the next prototype. Especially when you consider the new optimized 3D printing profile, so we might actually come up to about the same weight, but at 65% scale, like, it's only a 15% difference, but you can see that yeah, 15% doesn't sound like much, but it actually is quite a lot. Actually, if you assume 50% is like 1, then 65 would be 30% more. You know, for percentages work in weird ways. But yeah, that's the idea. We just make the plane larger. Not too large that it needs like more powerful EDFs to fly or anything. You just make the plane a little bit larger, so we're going to 65. That was just a gut feeling from me. I don't know if 65 is perfect. We might increase it or decrease it a little bit based on how the next prototype works. But 65 I kind of feel looks like a good starting point, because it's not adding too much weight, but it is adding a decent amount of surface area. This also means we have more internal space, which is pretty good, because if you look here, we have these two little slits for the EDFs, because the wall section in that area was actually so thin it wouldn't print properly, so I had to put these cutouts in. So like, we're really strapped for space inside of this. Like, everything barely fits in the current scale, so that's gonna be a lot easier for the next one. But yeah, so what I'm hoping from this is that we have the larger fuselage, the larger wings, like the fuselage also contributes a little bit to lift, but we get the higher wing area at the cost of very little added weight, especially with the new print profile. We can keep the electronics, we can probably actually reduce the weight of the electronics by moving to lighter speed controllers and potentially a lighter battery pack. And that is gonna be the next prototype. I don't think I will be trying to implement a swing wing to the next prototype, because if you look over here, and yeah, the ground is very messy, I was building 3D printers last night. So you look over here, that is a swing wing fuselage section at 65% scale. And the tolerances aren't quite working out. One of the sides still slips, so I need to adjust the size of the gears a bit. So it's not quite perfect. So the swing wing still needs a bit more work, so I'm just gonna go with a static wing prototype again until I get the swing wing figured out. And yeah, so we're not really doing anything. Well, I mean, I guess we're doing a little bit about the EDF performance, because the larger plane will also have larger air ducting inside, so there will be just less restrictive airflow, but we're not really purposefully doing anything about it. We are reducing the weight with the new print profile, a lighter battery and a light speed controller, potentially lighter servos, and we are increasing the lift by just making the plane larger. All that together, I hope, is going to be enough that the next prototype will actually stay in the air, like, for good, and not just for 5 or 10 meters. To which I have to add, if you look at the footage of the test flights, it does look a lot like the plane is stalling because the nose goes up quite hard, but I do actually have control over everything. Like, this is an EDF plane. It doesn't have a propeller in the front, So you don't have any airflow forced over the control surfaces. So once it's stalled, you're actually stalled. You can't control it anymore. And I was still able to roll using the elevons in this high alpha mode while it was going down. So that tells me it wasn't actually stalled. It was just not getting enough lift to climb. Like it wasn't stalled, it was just descending quite fast. So it's different on a technicality, but I still had roll control, which is actually quite nice, because I was a little bit worried about the effectiveness of the elevons on this. Like, again, this only has the 2 servos controlling the elevons. That is all the control you can get. There's no rudder, there's no ailerons. That's it. And I mean, elevons can work fine, but you have the issue that for roll, for simulating ailerons, you know, ailerons get more effective the further out from your rotation axis they are. So that's why they're usually at the very tip of your wing. But on these elevons, you can see that they're fairly close to the center of the fuselage. They're not fairly far out. And I was a bit worried that this was not going to have enough roll rate to be really controllable. But as it turns out, it has quite a lot of roll rate. Even in this high alpha, low speed scenario, it had enough roll rate to keep it steady. So that was just fine. So that's pretty good, because I was a bit worried about this aspect of the design, but it seems like it is completely unproblematic actually. So that is quite nice. And I think with that, I have said basically everything I wanted to say. So thank you for tagging along to this update of my 3D printed F-111 as I continuously keep working on it, keep refining the design. I mean, it's fun for me. It's fun to talk about my design. I know these videos aren't quite as popular as what I usually make, but this channel is stuff I enjoy, and currently I enjoy this. Don't worry, there will be more PC content. Like I recently got an RTX 2080 sent by a friend that's misbehaving. I'm gonna try to figure out what's wrong with that. And, you know, when an HW board competition comes along, I'm gonna be part of that again. And, you know, it's not like I don't have ideas. The main reason why videos are not coming out as much right now is university. I already did 1 exam. We have a group presentation next week, and then there's 2 more exams. This, like, the semester's kind of over, but, like, no, now I'm in the exam phase, whatever. So, you know, uni takes priority, so videos are whenever I have time. Anyway, I don't want this to stretch out more than it has to be. So, thank you if you're still here, and until next time, goodbye.